My name is Anna Steffi, and I'm part of Group 19.
I'm Zach Barnett, and I'm part of Group 19.
I'm Alana Tedwalis, and I'm also Group 19.
I'm Donglin Jia in Group 19.
And this is going to be our video for Lab 4 discussion questions. And here is the document. And here we go. Everyone's put in their work already, most of it. So the first discussion question is, discuss with your team the technical or conceptual issues you had performing the experiment and then how you overcame them.
I had a big problem trying to control the spinning of the cart, but I tried to overcome it by letting the cart reach rest before I tried pulling it and doing the recording. And then also the way that I pulled it and let go of it affected whether or not it would start spinning or not.
Yeah, I was in a similar boat. The string I was using probably wasn't the best option for this experiment. It was way too small to be taped down. It would just slide through. So I had to anchor it on my computer monitor and then hold down the string so it didn't go from side to side. But it eventually worked, and I think got some decent data out of it.
Yeah, I also have a hard time control the spinning of the IOLab. Eventually, I made it by just kind of let it go with a relatively more straight position, and so that you spin lesser than the previous times.
I also wanted to make sure that every single swing that I pulled back was the same, because otherwise I feel like my data would be a little more messed up, or I wouldn't be able to know the differences. So I would make measurements on the wall where I would eye it to let it drop, just to fix consistency issues. And it says, share your findings through your experiments with the members of your team and compare their observations with yours. And I think this question is in regards to decreasing and increasing the length of the pendulum.
And well, I think the first most notable difference is the period between the long string and the short string. It's obviously going to go back and forth quicker on the short string. So the data is going to be a little bit more crunched together with that observation.
Yeah, I definitely agree. I think that's really consistent with what I found as well. I could make the string a lot shorter than what it was because I had a pretty long thing, and the frequency increased in front of me just so much.
Yeah, I kind of done the experiment using two lengths, but the string length is relatively similar. I didn't notice that this frequency difference right in the data, but I kind of know they should be it should has a higher frequency for shorter string length.
And our last discussion question is, discuss with your team members your answers to question 12. And that is, in which of the two cases, long versus short pendulum length, do you find greater differences in motion of the pendulum between the two time steps? Why do you think that is? Does anyone have any ideas of what that could be? Or did you guys see anything at all?
I had a really hard time noticing, but yeah, wait, you go.
No, I was going to say the exact same thing you're saying. I can make assumptions based on the measurements I got, but taking into account that I don't know how consistent the amount of trials were versus the short versus long string. I don't know if it's the exact same amount. I don't know how much I can really trust that assumption. And past that, there's nothing glaringly obvious. It's like, oh, this is so much different versus the prior graph, other than just the width of the trail left behind.
Yeah.
So if there was a difference, does anyone like have any guesses of like what it would be between like 1,000th time step and a 100th time step and a 1/10 time step, I think, or whatever decimal places they are. Whatever.
Well, wait, I have a question. Would the time step be the same, I guess like value that you would use in force equals mass times velocity over time? Because it versus like mass times acceleration, but acceleration is just velocity times
Over time.
Yeah. Because if it's the same equation, then theoretically, a greater time interval would decrease the force. And if it's smaller, then it wouldn't have as much as an effect. But then also if the string is shorter, then I'm assuming the magnitude would be smaller. So then the time step would have a like greater influence on like the overall force, but I'm not sure if that's like the same thing.
Mhm. I mean, I think that would be the case. That time step that you're using to calculate force within a given like period would be the 0.01. And so the larger that number is, the smaller the force
Yeah.
is going to be, which would be like, which is also like a less accurate measurement. It's less measurements in general. Did we experience, I couldn't notice a decrease in force though.
Yeah, I couldn't tell if my eye was just like trying to see something, but it might have been moving like faster with more momentum, but
Yeah,
I couldn't tell.
it also decreases in motion. Like, yeah, I don't know. It's a good idea though.
Yeah, I think I might have, again, I don't really know because I'm not sure if I pulled it at the same exact angle and length when I tried it with a different time step, but it might have slowed down faster for, I don't remember which one. For the larger time interval at 0.01, but I don't know.
Mhm. It seems weird to me though, like, I don't know how I could conceptualize this, where, because if we have like two identical scenarios where like the pendulum's equal and like the pullback is equal, and you perform it, except in one you measure it every single like hundredths of a second, and then the other one you measure it every single thousandth of a second. I don't know like why that would change like actual force, like what actually is going on.
Yeah.
But how it changes like perceived motion might be something, but like for me, I don't know if like a change in time step should be, would it change actual force? Smaller would make it more accurate. We know that. I don't know, it's interesting.
Yeah.
Yeah, and back to the question, like the assumption thing. I think if the time interval is smaller, like 0.001, and make it an assumption, that would be easier for us to find for even the pendulum is long, because that gives us more time to observe, like the frequency is slower.
Mhm.
Yeah, I guess if it has more time to evaluate the data, and that would be preciser, I think.
Yeah, I agree. Something I thought about too was the idea that because a shorter pendulum has a shorter frequency, that there isn't as much time to make measurements in these time steps. And so it might look more drastic than it otherwise really is. And so in the motion that we observe with a shorter time step, we might observe like really like drastic, like more drastic motion, to whereas like a longer pendulum, you just have more time because it's slower, that you can take enough time steps with a shorter, you can take enough measurements with a shorter time step to where the motion won't be affected as much in the perceived sense.
Yes.
Awesome. All right, and I think that was it. So, does everybody think that we've covered everything?
Yep.
So,
Yep.